Hello guys, today I'm going to talk about Apache Kafka. Uh, First, what is Apache Kafka? Apache Kafka is the asynchronous distributed event streaming platform capable of handling trillions of events a day. It is created and open sourced by LinkedIn in 2011. Due to these advantages, it is very widely used around the world. More than thousands of companies. Its main clients are Uber, Netflix, Pinterest, LinkedIn, Oracle, the list goes on. Before step into the more details, I would like to talk about few concepts like what is a distributed application? A distributed application is a software that is executed or run on multiple computers within a network. These applications interact in order to achieve a specific goal or task. Traditional applications relied on a single system to run on them. Advantages are scalability, and microservices is one of the familiar example for distributed computation. And what is synchronous communication? It means that you call a web service and wait until it returns some response. All other code execution and user interaction is stopped until the call returns. So the client has to wait until it returns a success response or any error response. For example, a servlet call. Next one is asynchronous communication. In asynchronous communication, system puts a message in a message queue and does not require an immediate response to continue processing. This also known as fire and forget information exchange or message oriented middleware. Yeah. Now we'll get into the Apache Kafka. So here we're going to see these things in the coming slides, and I'm going to talk about them briefly. So what is Apache Kafka? Apache Kafka is a distributed streaming platform. So what is a distributed streaming platform? How it works in Apache Kafka? Apache Kafka designs its architecture in such a way that every broker, uh, a broker means it's a node, so it's having a topic. Every topic is divided into multiple partitions. With this option, so multiple producers can write the data parallelly into the partitions, and at the same time multiple consumers can read the data from the partitions parallelly. Then what is the publish and subscribe? It's a design pattern actually. So the publishers publish the data into the partitions. The subscribers who are interested in that data, they can subscribe for the uh, they can subscribe the data, and they can uh, consume it and process it as per their needs. It is a common option across all enterprise messaging services like TIPCO, ActiveMQ, RabbitMQ, and IBM MQ series. The second point is Apache Kafka stores streams of messages in a fault-tolerant, durable way. Apache Kafka having the option for replication factor. So a developer or administrator can change the value from 0 to 3. So if you store some data into one partition, the same data can be replicated into maximum 3 partitions. So with this approach, if any partition or the leader partition fails due to any uh, unexpected reasons, so other two partitions will come into picture. They play the leader role, and serves the data to the target consumers. The last one is it processes streams of records as they occur. The main advantage, and this option is not available in other traditional um, EMS systems. So Kafka can process streams of records as they occur. It means using the windowing option. So for example, for every second I'm going to hit some database and I can read the data, I can process it and store it into the partition. Is like a near real time data processing. This is briefly what is Apache Kafka and its capabilities. Next, we'll see uh, Kafka architecture. Here in the middle, we have Kafka cluster. As I told earlier, a Kafka cluster is a it contains a group of nodes or group of brokers. Every node works as a broker, and it contains a topic. Every topic is divided into multiple partitions. With this architecture, multiple producers can write the data parallelly into the partitions. Below we have the consumers. So consumers can read data from the partitions parallelly. In the right side, we have stream processors. From the 0.10 of Apache Kafka version, they have introduced stream processors. So as I told earlier, using the windowing operation, we can mention the time. So for every second you hit the some DB or some source and get the data and process it. It is a near real-time data processing, or we can store this data to Hadoop or Spark system. So big data can process the data. Big data architecture and big data systems can process that near real-time data. In left side, we have the connectors. Connectors are external systems. Apache Kafka has provided API, and it enables option for the external systems. They can connect to the Apache Kafka cluster. They can read data. These are similar to JWC connector or S3 connector. Next, we'll see why is Apache uh, Kafka. Though there is a number of or more EMS systems are available, or message-oriented middleware systems are available, what is the specialty of Kafka? So one thing is the scalability. How this is achievable in Kafka? It is with the help of a partition topic log. So as I told in few seconds back, every every topic is divided into multiple partitions. So with this architecture, um, Kafka can divide among consumers by partition and send those messages in batch. In the image, there is a Kafka cluster which is having two nodes or two brokers, and server 1 is having two partitions, server 2 is having two partitions. On these partitions, two consumer groups are having interest to read the data. In consumer group A, there is two consumers called C1, C2. In consumer group B, C3, C4, C5, C6. So how Apache Kafka is going to serve data to these consumer groups? In consumer group A, C1 and C2, two consumer nodes are available. So C1, C2 are requested for the data from two brokers and four partitions. So here Kafka architecture enables to uh, serve data to C1 from P0, P3 and C2 from P1 and P2. So it means 2 is to 4. Okay. Same way in consumer group B, there is four consumer nodes and we have four partitions. So here data is served in a one is to one manner. So it means one partition, one consumer. In consumer group A, one consumer, two partitions. It's like a one is to two. This is the unique and familiar option available in Apache Kafka, and it's enables to read and write data parallelly from Kafka cluster. So with this reason, only uh, it can grow horizontally as data grows. Who are Apache Kafka clients? There is thousands of Apache clients are there in the market now. LinkedIn is one of the major client because it is able to process. They have uh, architectured their hardware to process 1.4 trillions of events per day. Uber also one of the major customer for Apache Kafka. They leveraged their hardware to process trillions of events per day. At the same time, Netflix is able to process 400 billion events per day. 8 million events or 17 GB per second in a peak time. So this is the capability of, of Apache Kafka. And there is many use cases are there with Apache Kafka, like messaging, website activity tracking. With the help of website activity tracking, website owner can know who is visiting their website frequently, which pages they are visiting, how much time they are spending on each page. So with this information, they can make relevant changes on their website, and they came to know who are their uh, target customers. And Apache Kafka is able to provide metrics. This involves metrics involves aggregating statistics from distributed applications to produce a centralized sense of operational data. Then it is also one of other main use cases: log aggregation, stream processing, event sourcing, and commit log. And a commit log is one of other interesting feature in Apache Kafka. Kafka can serve as a kind of external commit log for a distributed system. The log helps replicate data between nodes and acts as a resyncing mechanism for failed nodes to restore their data. Um, and what more Apache Kafka can provide, we'll see in the later sessions. Um, so why major clients like who are who are handling big data, who are having more customers like LinkedIn, Uber, Netflix, are preferring Apache Kafka than others? Here the reason: Kafka gets used for fault tolerant storage. Kafka replicates topic log partitions to multiple servers, aims to provide a unified, high throughput, low latency platform for handling real time data feeds. So, this is the capability and advantages of Apache Kafka. So, in the next session, we'll see how to install Kafka on Windows OS, and we can see a sample example how to pass data from topic to consumer. Okay, until then, have a good day. See you.